Our next theorem is called the mid-segment triangle, and we're going to look at learning target 7.4b says I can use the mid-segment of a triangle. So we're just going to apply this. So the mid-segment of a triangle should look very similar to the mid-segment of a trapezoid from earlier. So let's start there. The mid-segment of a triangle is parallel to the base. Okay, so it's parallel to the base, and the mid-segment equals half the base. Okay, so basically if you look here, GH is half of FE. Okay, so we can also do this and take 2 times our mid-segment and that would equal the base. Okay, so as we get going here, some other things to be aware of. Since these are parallel, that means this angle and this angle are the same and are equal. Okay, and then this angle and this angle are the same because these are similar triangles. So if I zoom in a little bit, if you think about it, this is a triangle right here, and it's similar to this big one. These would be what we call corresponding angles. Okay, and so that is something to be aware of. You should already kind of know from similarity, because similarity means all the triangles are the same. Now I'm going to also talk about one more thing. If I draw in basically and connect the midpoint of all 3 sides here, and you don't need to draw this, I just want to show this, all of these triangles right here would be the same. Okay, all of these would be the same, and this angle would be the same here. Okay, and all these would just kind of slide across. This angle up here, D, would go right here, and then this one would be right there. And so I just want you to kind of notice that a little bit, that all of those would actually be the same. So that could come up when you're looking at your practice. Okay, all right, so what does the mid-segment do? Well, the mid-segment of the triangle connects the mid-segment of 2 sides. So if we want to find the values here in this example, if A to D is 9 right here, then these are parallel, and they tell us these are the mid-segment. This is a mid-segment, then this is 9, and this length down here would be 18. Okay, so we'd have 9 and 18. Okay, and then obviously they're proportional to the other side. And then how would we find D to E? Well, D to E would be half of this side right here, which is 14 right there. So it would be half of 14, which would be DE equals 7. Okay. Now, if we're solving for x using the mid-segment formula, this is where we always like to double it. Okay, so if you remember, we could have done that on the last one and set up, remember, so like on the last one, this is basically x. We got 2x equals 14, so x equals 7. So if we come over here, if this is my mid-segment, I want to double it. So we're going to do just what we did there. 2 times x plus 3 equals 6x plus 1. This would give us 2x plus 6 equals 6x plus 1. Ooh, this isn't fun. I don't think I made a good example here. Oh well. We subtract 6x. We subtract 6 over here. We get negative 4x equals negative 5. Divide by negative 4. It's not so bad. X equals 5 over 4. So that's not so bad. It could be worse. Okay, all right. Woo, let's have some fun here. Use the side splitter and mid-segment theorems to determine the value of the variables. Woo-wee. So we got to look around. We got some stuff going on here. We got x. Here's x. Here's y. And here's z. And so we got some cool stuff going on. You got some relationships going on. So we got 1 triangle, 2 triangles, 3 triangles, right? We know the base. So if one of these is the mid-segment, we can find it pretty easily, okay? But I think we need to know the outside here to determine if one of these is the mid-segment, okay? If I had to guess, y looks like a mid-segment, okay? But I think we need to figure it out first. So how could we figure it out? Well, we got to find x. So we need to find this side, right? And we can use, notice these are all parallel. These are parallel. So we can use our side splitter theorem here. Okay, so let's set that up. Let's set up our side splitter here to find x. Okay, so to find x, we got these and these, right? So we got 4 over x plus 2 equals 3 over x. Okay, so now if we cross multiply, we got 4x equals 3 times x plus 2. So 4x equals 3x plus 6. Take away 3x. So we get x equals 6. Okay, so that means this is 6 down here. Okay, and this would be 8, which means y, which means if this is 12, so I want you to see this. So this is 12, this is 12, this is 9, this is 9. That means y, is a mid-segment. That means y is a mid-segment. So I'm going to come over here. If y is a mid-segment, then y equals half. Let's do this. Then 2y equals 30, or y equals half of 30, depending on how you like to look at it. Either way, y is equal to 15 right here. Okay. So then how can we find z? To find z, we can use proportional relationships here. So we can use some proportional ones. And so if you think about it, I would just use to find z, we got this triangle right here. Okay. And so what I would do is recognize that I got this side relationship, z over 15, is proportional, and this is getting kind of crazy, proportional to this triangle relationship right here. Okay, so those are our two triangles. So we got 15 to z, so bottom to bottom, and then you just got to pick one other. Okay, and if you think about it, you got to use this right here. We could just use this. Would be if I did z first, 12 and 4 would make 16 to 12. that would be kind of how our relationship works. Oh, wait, no, not, yeah. So, or if you went the other way, 15 to z equals 12 would be 12 to 16. You could also use 9 to 12 because this is 9 to 12. 9 to 12. Okay? Or you could have used the whole side to find z. We could have went 15 to z and then 24 to 30, 18 to 30. But either way, when we get z here, we're going to get 12z equals 16 times 15, which is 240 divided by 12. Z is equal to 20. And that's how we kind of use our different theorems to kind of find different lengths in those triangles.